All right, we're going to talk about systems with three variables. So the number of variables you have is you're going to need that many equations, okay? And sometimes you're going to be able to weed out all the variables, and we'll kind of talk about what happens if I get down with 1x and I can't find x, y, and z, and they aren't there. What that is saying is that we actually have a connection between, it's a line, it's a linear line where we have an x and y in a line. That's our piece there. But when we're looking at systems with three variables, what we're going to do is we're going to use elimination to kind of get rid of those variables. And so it doesn't really matter which variable you pick first to eliminate. What's going to happen is so on my first example here, what I'm going to do is I notice that I have a positive z, a negative z, and a negative z. So I'm going to go ahead and eliminate my z. Okay? And I notice that my first equation here has a negative y and a positive y. So I'm actually going to combine these two functions right here into one function and eliminate my y's and z's. So if I were to add this together, 2x plus 4x is going to give me 6x. Negative y plus y is 0. Z minus z is 0. 4 plus 14 is 18. And so now I have 6x equals 18. I can solve this. That gives me x equals 3. Now, that's nice because what that allows me to do now is substitute anywhere I have an x, I can substitute in 3. So I'm going to go ahead and combine these, the top equation and the middle equation, because that's the other one where I saw my z's were going to go away. Okay, so I'm going to combine those z's, they go away. So I have 2x plus x, which gives me 3x. 3y minus y is 2y. My z's go away. 4 plus 11 is 15. So here's my next equation. I'm going to just write this over here. 3x plus 2y equals 15. Now the nice thing is I already have my x. So I'm going to plug that in. 3 times 3 plus 2y equals 15. 9 plus 2y equals 15. Subtract my 9. 2y equals 6, or y equals 3. So y equals 3. So now I have my x, I have my y, I now need to find my z. Well, I'm going to take these two values and I'm going to plug it into one of these. Okay, it doesn't matter which one you plug it into, just pick one and plug it in. So I'm going to plug it into the top. So I have 2 times 3 minus 3 plus z equals 4. Well, this gives me 6 minus 3 plus z equals 4. 3 plus z equals 4. Subtract my 3, subtract my 3. Z equals 1. Now, if I want to write this in an ordered triple, I would say 3, 3, 1. There's my ordered triple. Okay? Now, we're going to do the next one. I want to show you one in which the two of the variables don't eliminate all at once. So that was the nice thing about this one, is I was able to get my x right away and be able to plug it in. So let's go ahead and erase this. And let's look at this new system of equations here. So here I have x minus y plus z equals negative 1, x plus y plus 3z equals negative 3, 2x minus y plus 2z equals 0. And I want to find x, y, and z that satisfy all of these. Okay? So what I'm going to do is pick a variable and eliminate it from out of these equations. So that way I can pare it down to two variables and 2 equations. So I'm actually going to eliminate my y's, okay? Now the reason I chose y is if I look here at my first equation, I have negative y, and then my second equation has positive y, and my third equation has negative 1. So I chose y because, first of all, their coefficients are 1, so it makes it nice. I don't have to multiply by a constant. If I picked x, I would have to multiply the top equation probably by maybe a negative 1 added to the second, or a negative 2 and added to the third, okay? So what I'm going to do is I'm going to combine these two equations here, okay, to get rid of the y out of these two equations. So I have x plus x, which is 2x, z plus 3z, which is 4z, negative 1 minus 3 is negative 4. Now, I have to use the third equation. And what I'm going to do is I'm going to use the third equation with the second equation. It doesn't matter. I could have used the first and the third, but since they're already opposite, I'm going to use the second. So I have x plus 2x is 3x. Y's go away. 3z plus 2z is 5z. Negative 3 plus 0 is negative 3. Okay? So now I have two variables, two equations. I now need to eliminate one of these variables. Does it matter which one I use, eliminate? No, it doesn't. I'm going to go ahead and eliminate my x's just because I notice here that I have a 2 and a 3. I know that 2 and 3 both go into 6. So one of them has to be negative, one of them has to be positive. So I'm going to multiply this top by a positive 3. And I'm going to multiply the bottom by a negative 2. Okay? No reason. You could just pick negative 3 and positive 2, and you're still going to get the exact same answer. So I'm going to multiply 3 by this top equation. 6x plus 12z equals negative 12. Negative 2, so I get negative 6x minus 10z equals 6. And now I'm going to add straight up and down. The x's go away. I have 12z minus 10z is 2z equals negative 6. I'm going to divide by 2, z equals negative 3. So in my ordered triple, I now know that z is negative 3. Okay? So now what we're going to do is, get that right? Okay? So now I'm going to look at getting my x or my y. Okay? All right, so I'm going to take this negative 3 and plug it back in. One of the things that I want to warn you guys about is it's very, very easy to make a mistake in 3 variable equations, okay? Usually the funny thing is, it's usually an addition problem. So you usually add incorrectly. So like for instance, x plus x, I want to make sure I get 2x. Z plus 3z is 4z. Negative 3 is negative 4. 3x, 5z, negative 3. So sometimes you just want to make sure that your addition and multiplication is all correct. So I'm going to take this negative 3 and plug it back in. I'm going to plug it back in here. So I have 2x plus 4 times negative 3 equals negative 4. 2x minus 12 equals negative 4. Add my 12 over. 2x equals 8, or x equals 4. So now I know x equals 4. I'm now going to take this 4, plug it back in. I'm going to plug it into the top equation. So I have 4 minus y minus 3 equals negative 1. 1 minus y equals negative 1. Subtract my 1, negative y equals negative 2, or y equals 2. All right? So there's my ordered triple. I now have found where those 3 equations are going to intersect.